Welcome, guys, to Unit 7 Target 1B notes, where we're going to talk about the unit circle. You can see our first thing is, what the heck is the unit circle? Well, it does relate back, you're going to see, guys, to what we talked about previously when we discussed what a radian was. Notice a radian, right, was the measurement of an angle based on the length of the radius of a circle that rotated around the circle and created the angles. And that allowed us to measure angles using the length of based on the length of the radius. And so what the unit circle is, guys, is it is a circle with a radius of 1 where the vertex is at the center. So sorry, I said that backwards. It's a circle on the coordinate plane with the vertex at the center and a radius of 1. So we have a fixed initial side length of 1 here, our radius of 1, and then we rotate that radius around to create the circle. And so what we now have is a circle with a radius that we know the length of, and we can then use that length with angle measures to get angle measures on that circle. And since it's a radius of 1, that allows us to do some things that we wouldn't be able to do otherwise. We're not going to go into as deep a discussion on the unit circle as we normally would and where everything comes from. But what you see here, guys, is the traditional diagram and information that you're going to need to know from what is called the unit circle. Notice in each quadrant, there are 3 angle measures. In the first quadrant, 30, 45, 60, 120, 135, 150, and so forth in quadrants 3 and 4. We have our 4 quadrantal angles, the angles right on the axes in between the quadrants, 0, 90, 180, 270. Not only are they in degrees, but you can see they're also in radians. And then we have these ordered pairs all around the outside that are the ordered pairs of points that are on the circle that correspond directly to the terminal side of each angle. So you can see a 30-degree angle goes from our initial side up to the terminal side. And if you extend that terminal side of a 30-degree angle till it hits the circle, you get this ordered pair. Now, the one thing I will explain, guys, is where those ordered pairs come from and why do we care about 30, 45, and 60 and so forth in every other angle? Well, both of those questions go back to the special right triangles you learned about in geometry. You learned about 2 special right triangles, a 45-45-90 and a 30-60-90 right triangle. And what you learned was that the side lengths, the side lengths of those right triangles were always going to be set in a specific proportional relationship. You had 1, 1 in square root of 2 for the legs and the hypotenuse of your 45, 45, 90, and the short leg was 1, the long leg was square root of 3, and the hypotenuse was 2. Now, don't panic if these were horrible for you in geometry. We're not actually going to be using the special right triangles, but I'm just trying to show you where some of these values on the unit circle come from. Remember, the unit circle, the radius has to be 1. And if you look here, guys, notice what I can do with this terminal side is draw a horizontal and vertical segment. And essentially what happens is the terminal side of our angle becomes the hypotenuse of a right triangle here. You can see I have a right triangle here and a right triangle here. So essentially, this hypotenuse has a length of 1. So if I take the special right triangles from geometry and I change the relationships of the sides so that the hypotenuse is 1, I would get a special right triangle with different side lengths that have a hypotenuse of 1. Notice if I divide square root of 2 by square root of 2, I get 1. Now, it's tough to do this without being there, but when you divide 1 by square root of 2, all right, you get this fraction, 1 over square root of 2. However, math people, don't ask me who, I don't know who they are. I would like to have a word with them, but it is what it is. Don't like having radicals in the denominators of fractions. So they do something called rationalizing the denominator. And what we do is we multiply the denominator by itself because square root of 2 times square root of 2 becomes just 2, which gets rid of the radical. and whatever we do in one part of a fraction, we have to do to the other. So what we started with is a fraction that's 1 over square root of 2 is actually equivalent to square root of 2 over 2. Again, there's absolutely no difference in them numerically. The appearance is, though, the big deal, because here you have a radical in the denominator and here you don't. On the SAT and any textbook, and almost any resource you're going to see, almost all fractions will be rationalized like we have here in purple, rather than left unrationalized like we have here in green. So it is important to see that. And so what we do when we divide everything here by square root of 2, right? So what I'm doing actually here is I'm dividing by square root of 2 over 2. That gets me 1. And when I divide by square root of 2 over 2 here, right, that gets me the rationalized square root of 2 over 2 and square root of 2 over 2. Same kind of deal here, except we don't have to worry about dividing by a radical here, because the hypotenuse is 2. So I divide 2 by 2 to get 1, divide 1 by 2 to get 1/2, and divide square root of 3 by 2 to get square root of 3 over 2. Notice the ordered pairs. The values in the ordered pairs here in this first quadrant directly correspond with the legs of these special right triangles that we have once we get the hypotenuse of each equal to 1 by division. All right. And so what we see is that this point here, this point right here, has a vertical distance of 1/2 and a horizontal distance of square root of 3 over 2, which is then the x and y coordinate of that point. This is x and that's y. Same deal here. This is a 45, 45, 90, the green outlined triangle here. So the leg, the hypotenuse, or sorry, the leg and the leg, the horizontal and vertical distance is square root of 2 over 2, which is our x and y coordinate. All right, I'll be honest with you, you're not really going to need to know how to construct and all of the inner workings behind how the unit circle is created. What we are going to have to know, guys, though, is how do we use the unit circle to help us understand our trigonometric relationships. Another question some of you might be asking is why 30, 45, and 60? Why not a 50-degree angle? Why not a 70-degree angle? Why not a 20-degree angle? I'll be honest with you, the best answer I can have is somebody a long time ago felt that 30, 45, and 60 were the most important angles to use. It's somewhat arbitrary, but it's become an accepted practice. Now, what you'll notice, though, is that the 60-degree angle here is mirrored, reflected. If you take this 60-degree angle right here and you reflect it, you get the 120-degree angle, right? So each angle measure in the second quadrant is a reflection of each angle measure terminal side in the first quadrant. And look at the ordered pairs. Notice the ordered pairs of those points on the circle are almost the same exact value, except that the x coordinates are now negative because we're in the second quadrant. In the second quadrant, x is negative and y is positive, where in the first quadrant, both coordinates are always positive. Take a look at the third quadrant. Again, it's another reflection, and you can see square root of 3 over 2, 1/2, negative square root of 3 over 2, negative 1/2, 2, 10, and 30 are in the same position, except that the ordered pairs are now all of our x and y coordinates are negative. And then again in the fourth quadrant, now the difference being that x is positive and y is negative. So we see that this first quadrant is really honestly the most important quadrant, and then all of the other quadrants, the ordered pairs are found by just changing the sign on the coordinates to match the appropriate values in that quadrant going forward. So again, that's a little bit about the unit circle. If you're super confused, don't stress about it. You can look it up. There's definitely a lot of information out on the internet about the unit circle, and you can go more in depth. But really, we're going to be more concerned about using the unit circle than we are about necessarily understanding how it was created and everything. So let's go to these problems over here. So we're going to look at a few of these. All we're asking for in problems 1 through 12, guys, is can you look at the unit circle, find the angle measure that we're asking you for, and give us the ordered pair, the x and y coordinates of the terminal side of that angle on the circle. So let's look, for example, 5 pi over 6. So that's in radians. So I need to scan the unit circle, pi over 6, da-da-da-da. Oop, there's 5 pi over 6. So this terminal side right here, right, gives us an ordered pair of negative square root of 3 over 2, 1/2. And so that is what we are looking for here. Negative square root of 3 over 2, 1/2. That's all we're asking for at this point. All right, so let's go with 7 pi over 4. So let's follow here, and we get, right there, 7 pi over 4. So I follow that terminal side of that angle measure to the circle, and I get square root of 2 over 2, comma negative square root of 2 over 2. So the ordered pair, the values of the coordinates at that point are square root of 2 over 2 and negative square root of 2 over 2. All right, what happens if we're dealing with a negative number? Let's do some negative numbers in degrees here. Negative 90. Now remember, negative 90, we have to follow the opposite direction. So negative 90 is actually the same thing as positive 270, right? If 90 is here going positive, it's going to be in the opposite place going negative. So we can see here, I'll use a different color since we're doing negatives, right? That is this value here, and we get the ordered pair 0, negative 1, and we'll do one more negative one together here, negative 30. Now, negative 30 is going to be the inverse of the reflection of positive there. So if I go up 30 to get to positive there, and I go down 30, which puts me right here, negative 30 and positive 330 are the same, and we get this ordered pair, square root of 3 over 2, negative 1/2. All right, so that's the end of our first video here in this unit. All I want you to be able to do at the end of this video, guys, is use the unit circle. If you're given the angle measure of a terminal side, find the ordered pair, the x and y coordinate of where that side hits the unit circle. What we're going to do in the second video is actually talk about how do we then use those ordered pairs to help us know the values for the sine, cosine, and tangent of these angles in our unit circle. All right, I'll see you again when we get to the second part of this video.